Hi. Okay, cool. I'm trying to close Chrome, and it's taken 2 minutes so far. Not done yet. Yeah. Hey, everybody. Let's see. Let's start with Ryan.
Hey, how's it going?
Doing well.
Let's see. So I had a question I had an easy question that was regarding the use of I plus equals 1 versus I plus plus. I don't know if that's just for readability or what, but then I had a more in-depth question.
Okay, for the first one, I think both are fine. What I'm not a big fan of is code that does like, actually, I'm gonna open up a, share my screen, hold it here. Okay, there's me. 1 minute. I got too much going on here. I need to share my screen. Okay. Let's see. Computer, what are you doing? Okay. Yeah. So I'm not a big fan of code that looks like this generally, with like the something getting incremented inside of an array index or so forth. I especially am not a fan of this, but some people like it. So the reason that I generally do I plus equals 1 as opposed to I plus plus is that you can't do this. I guess you technically can, but it's weird. Nobody would write that code. So it's to discourage this, which I don't like personally. That's all. Both are fine.
Okay, perfect. And then I guess a bit more complicated question was just regarding void functions, and this came up when I was taking the practice midterm, specifically the recursive problems where we're limited on lines. And I was curious how Java handles void functions when you're like, let's say you want to return a void function or true or whatever the case is. And I guess the same thing would go for how it handles typed methods as well.
And sorry, it's if you want to do what exactly?
So let's say you were trying to be creative and keep it all in one line. So you return a voided method or true so that it would run another function as part of your return call. You know what I mean?
Let's see. So you have like public void and x, whatever. And then somewhere else you're trying to call it and do a what, an and type thing?
Yeah, an and or an or something like that.
Oh, so you want to call two functions on the same line. Got it. I see. Yeah, interesting question. Okay, so let's say we have two functions. And I want to call them both on the same line. Let's see. I think do this. I think you can put it in a comma. That's my guess. Try that. I think that's allowable in Java. I don't remember.
Yeah, I'll play around with it in the interpreter.
Cool. Yeah, but the comma I think will work. Cool.
Thank you.
Sandra.
Hi, Professor. I have a question about inheritance. So you mentioned that we should not use inheritance to implement a has-a relationship.
Right.
And regarding the set and s single linked list example, I understand that a list is not a single linked list, but how does that implement a has-a relationship?
Let me look at my example. Let's see. Oh, I know what you're getting at. Yeah. Let me find the specific slide real quick. Okay. So if we look at this here, right. So are you talking about this slide or?
I was looking at the slide for last class, but I guess this works as well. It's just a general question, like,
yeah.
How does set implement single linked list illustrating has a relationship?
Right. So this would one way to implement a set is to let's see. Right. So if you do this set extends S list, what you're effectively declaring is that a set is a list. That's a weird thing to do. That makes sense. The reason that it has a relationship is that the way that we implement a set, like if you use an S list to implement a set, it might look something like this. So let's say we decide, is this visible, by the way? Can you see my text window?
Yes.
Okay, cool. So let's try making like a, I'll call it February set, whatever, because it's February. And then you might have a private S list of T items. And then when someone does like, maybe I'll have private Boolean contains S list T, or sorry, contains code. Actually, it's probably public. So in this sense, the reason I say that I'll say that a February set has a S list. And that, what I mean by that is that a February set uses an S list to store its data. So I would call this a has a relationship because it has this as an instance variable. Does that make sense?
Okay. Yeah.
Okay.
That does.
Now, if by contrast you did February set T extends S list T, then you add this method T, and it's like part of it. It's like you're getting like you can get the same functionality out of it. You can put the exact same code even, almost. That is very similar to above. And so I guess the first question I have for you is, do you think this is a relationship? We'll just start there. We'll go back to your question in a moment. So conceptually, is there a relationship between S list and February set, regardless of the code? I'm going to take it away. I feel like I'm talking in circles a little, but I'll have you answer this question. So what do you think?
I don't think it is a relationship.
Right, exactly. So no, because a set doesn't have, as I noted in the slide, things like an ith item. Doesn't make sense to have get I. Okay, so let's put this code back. I'm going to delete this thing because it's not a good idea. And so you're asking, why is it has a relationship? The way I think about it is that one of the things that a February set has inside of it is an S list. It uses an S list to do something. It's a little confusing because it's the only thing it has, so it doesn't feel like it has a relationship. But maybe you could have other, we don't have enough other data structures yet, but you could do, I don't know, like display set on, I don't know how to, I don't really have a good example, but whenever we have bigger classes, you can certainly have data structures that, or sorry, you can have classes that have lots of other stuff. Does that make sense?
Yes, I see. And
Yeah. Well,
I guess my question.
Slide. Go ahead.
Yeah. Like regarding like last class slides, there is when you said that we should not use inheritance to like capture a certain feature that a set has, and list 61b does not have. So I was wondering, can has a relationship mean like has a certain feature?
Yeah. So it could be that there has a certain feature, like it has a method that does something in particular, if I understood your question correctly.
Yes.
Yeah,
Yes.
certainly. So that's definitely a thing. Let's see. Has a relationships composition. Looking for this over. I'm trying to remember. There's a great. Yes, there we go. Yeah, there's a phrase known as composition in programming. Some languages, like Go, for example, they tend to stress has a relationships a little more formally. But I can't really get into it here. But yeah.
Sounds good. And one very last trivial question.
Mhm.
In the print, like default method, you mentioned in the last lecture, you like directly called size using like size parentheses. I was wondering, like, would there be a case where this dot, a certain method must be written instead of just the method name?
I see what you're saying. What's the example I have here?
The when you were talking about
Oh, the default method, right?
implementation.
Yeah.
Yeah,
Okay. So your question is there ever a circumstance where we need to say this? Is that right?
right, yeah.
Interesting question. Is that ever necessary? I can think of one circumstance, maybe. Well, no, never mind. That won't do it either. Oh, never mind. If you ever need to say this, now that I can think of, there might be one, but I can't think of any reason you would ever need to.
Cool. Thank you so much.
Yeah, unless you had to. Oh, I thought maybe. Nope, still not gonna happen. Never mind. Yeah, there's no local scope that would ever conflict. So yeah. Somebody thinks of something else, let me know. All right. Was that Sandra just talking? Yes, okay, cool. Elijah?
Hey, Professor. So I've got two quick questions. One is when you're making the vengeful S list during lecture, so you tried first copying and pasting the contents of like S lists remove last, and that didn't work because it was private. So then you said, okay, I'm just going to do like super dot remove last. But what would you do if like the supers remove last didn't actually return the items that it was removing? And then you wanted to do like the printing out of lost items, because then you'd have like kind of a problem there.
I think what you would probably want to do is presumably you have a different method that would be super.getLast, right? You could do that instead, right? So I think this should work fine. Let me know if it doesn't for some reason.
But like, let's just say, for example, like that's actually a good point. But if it didn't do that, then like,
If there was no getLast method or something.
Yeah, could you just, because you can't like actually remove it yourself.
Correct.
In the vengeful S list.
Yeah. It is possible that the API or the methods available to a subclass are not sufficient to do a job, right? So if there's literally no way to get last item in the subclass, then yeah, it wouldn't be possible to do.
Then you'd kind of need your own API.
Yeah, I mean, basically, yeah, there are things that are impossible, I think is the boring answer.
Okay.
Yeah.
And then my second question was, I don't really get the difference between extends and implements.
There isn't really a difference. It's just whether or not the thing that you're extending is a interface or a class. So if this thing over here is a class, then use extends. If it's an interface, use implements. That's it.
Okay, cool.
Yeah.
Thanks.
Yep. Maybe the way to mnemonic that I use is that implements take something that is abstract and it makes it concrete. Make sense? So you're going from the realm of platonic ideals to our real universe. That's the way I think about it. Implements is where you transcend from the heavenly world to the earthly world. That's the special word. All right, Rahula.
Hi, Professor. So
Hi.
my question is that, so I watched the lecture about the interfaces, and then so when we are not trying to write a method inside the interface, which I mean, if we write the method, we write default, right?
Yep.
But if we don't write any method and we only write the signatures of the methods, what's the benefit of having interface?
Right. So the reason is that it allows us to write code that's general. What I think about it is this example here, as a sort of toy example. If I want to write code that is able to return the longest string in a list, but there are many different implementations of list out there, I need an interface as a common way to formally specify that like this list object has all the methods I want. So in other words, like this early example in lecture 8, in theory, without a list interface, you're going to have to write a longest method for every single implementation of a list. By having this formal list specification, right? Like we need, like it allows the Java compiler to be lazy and say, okay, all I need to do is look at the list signatures and see if it has the methods I want. There's an alternative approach, which is I could imagine that what the Java compiler does instead is I just have like something, I don't know what it is, just like I'll call it var, right? So imagine I have something called var, which is an unknown type, and then the compiler's job is to check anytime you call longest that the object that's being passed in has a get method and anything else, a size method. Yeah. So you could in principle do that. It's another approach to programming, but it's a little messier. But you could in principle like have the compiler check at compile time if the object being passed in has all the methods that someone's trying to use. The advantage of this approach is it's just like, it's cleaner. You don't have to, everything is just very explicitly written. So if I had to give a short answer, it would be that the advantage of an interface is that it allows you to concisely but formally specify the behavior of some entire class of classes. Make sense?
Yes, and then to know like which method is being called, again, we should like do the 2 steps that you told us, right? Which is see the compile time and
and it is annoying. One day I'm gonna figure out how to teach this class without having to teach these rules because I find it boring. Oh yeah, this is the simplest way I know how to teach it now. Maybe one day, this is a new version, but maybe one day I'll find an even simpler way of explaining it. But yeah, I think this covers everything. I should note there's one kind of annoying detail I hid, which is that when doing type checking, we like allow subclasses to fill superclass boxes. For example, sniff animal A can accept a dog argument. So I said that, I didn't explicitly say it anywhere on the slide, but it's like something that I think students maybe get a little confused about. But anyway, I'm not gonna go there. My point is like, I've tried to make this as simple as I possibly can, but I still feel like in the entire 40-week class, this is the single topic that remains elusive to me in terms of how to teach it well. So sorry if it kind of sucks.
No problem. But one other question is that, so I know that we can actually assign a subclass to a superclass variable, right? Could we do the other way around, or do we get an error if we do that?
You would get an error if you did something like, let's say, cat C equals new animal. Yeah,
right.
That would cause a compile error. If you do a cast, which is in lecture 9, I think. Do we have casting yet? Sorry. Yes. Okay. If you did this, this would crash at runtime. So yeah, can't do it.
So even if we cast it, we cannot run it?
You can run it, but it'll crash at runtime. And the argument is that a cat may have instance variables that don't exist in an animal. So if you were to actually allow this to happen, then it wouldn't make sense. Like imagine something like this. I mean, we can go really extreme and make it less weird and say, list of integer equals list integer new object, right? Like this new object doesn't have any instance variables. So even though you can technically cast it as a list of integers, it doesn't have any like items in it. So yeah.
But what if like object and list, they both have like all the methods?
Say again?
But what if object and also like
list? I see. So that's an interesting thought. Let's imagine that we do cat implementation 2, or like Friday cat equals Friday cat new Thursday cat. So even if Thursday cat and Friday cat are literally exactly the same, this will still crash. Like if the only difference is the name of the class, this will still crash. And the reason is that the runtime type checker is just going to say, sorry, these don't match.
We can do it with doubles and ints, right? But not with the.
Yeah, I see what you're saying. So yes, it's true that you can do things like something like that. Yeah, so that's allowed, but that's because of special rules surrounding primitives in Java. Yeah.
Makes it simple for us, I guess.
Yeah, exactly. Yeah. And by the way, all these little rules, I don't teach them specifically because they're just not important enough for you to all memorize. So yeah. In some other person's Java class, they might ask you like, what, will this crash in this circumstance? That's just not something I find important.
I see.
Yeah. So don't worry, I will not ask this question on an exam. I find these questions super annoying.
Thank you. Can I ask one?
Yeah,
last
please
question?
go ahead.
So if we have I was trying to do the homework for array list for array deck, and then let's suppose we have only 8 elements, right?
Mm-hmm.
And then so we have the first the 0th element of the array is filled up,
Mm-hmm.
and now we are trying to put in something. Now we are trying to call add first.
Yeah.
So I know that we have to go to the 7th element, right? Because it's a circular array.
Yeah.
But if we go to the 7th array, and then we want to so now 7th array is also filled with something. A 7th element is also filled with something. So when we call add first again, where should we go? Should we go to the 6th element now?
Well, so you're saying if it's basically a situation kind of like this, where the array is full, right?
Not full.
Not full. Okay, let's see. It's not full yet. Tell me what changed about the array.
It only has 2 elements, and the
two.
first
Okay,
element
yeah.
is filled, and the
Got it.
last.
So let's do. Let's see. Okay. So let's see. Size 2. Next first is 7. Next last is 2. By the way, this is just my implementation. There's other ways to do this, but yeah.
But 7th is also filled.
7 is also full. Okay, yeah, right. G. So it's size 3, and next first would be 6 in that case. Okay.
Yeah, I was wondering if we did add first, then where should we put it? But we have to put it in 6th element.
Right. Yeah, that makes sense.
Yes.
Yeah. So basically, it just keeps going that way. As you add first, you're going to be scooting along this way. Yeah.
And then our add last would go the other way, right?
Right. Yeah. So add last will keep incrementing this way.
And then whenever they cross each other, that's when you know that it's filled.
Yeah. Or when the size is equal to the array size. Either one is a good condition. And I should note, by the way, you have some freedom. This is just the way I did it. But yeah, there were people last time who were like, why not start it at 0 and 0, so that wherever, if you call add first or add last, it goes in this position. That also works. I just found it was cleaner to do it this way. So it was my suggestion to try it. But yeah.
I see. But then if we had an element at 7th, if we had something on the 7th element, we did remove first, then we should go back to 0th element.
Right. So if I remove first, this will go to, that'll go in. This will become 2. Next first will become 7.
I see.
Make sense? And then you remove first again. What is next first going to be next?
7, right?
Yeah. What happens if the next remove first, though?
What was the question?
Oh, if we call remove first, what happens next?
Oh, then next first should go to 0.
Right. Okay. Yeah, you got it.
Okay. Yes.
Great.
Thank you.
Cool. Good luck. The resizing is the hardest part of the whole project. All right, Brant.
I know that the extends keyword automatically inherits methods, but what happens if we specify a method in an interface without the default keyword?
Let's see. So, what happens if we do what?
In
Sorry.
an interface, if we specify a method that's not in a subclass, but without the default keyword.
Oh, I see. So what happens if you try to define an interface and then you just try to, right, let's see, we go to 8. Where's my print method? Hold on. Right, what happens if we do this basically?
Yes.
Yeah, the compiler will just yell at you and it'll say methods in abstract class must be abstract or something like that. And it won't do anything.
But for extends, we don't need it. Just automatically takes all the superclasses and methods, inherits all of them.
Well, if you're in an interface and you don't use the word default, it just won't compile. That's what
Yeah.
I thought the question was. Did I get it
Yes.
wrong?
No, that was my
Wait,
question.
yeah, it just won't do anything. Yeah. Cool. Consuelo.
Hi. So this came up briefly, quickly during the beginning of the live Q&A, but if we are extending a functionality of a class, could we use super to manipulate private fields, or are we explicitly limited to public-facing methods and fields?
Only public. Can't touch anything private, field or function.
Even if we like explicitly make like a super object.
Yeah, even if we say super dot size, it still won't let you do it.
Okay.
Yeah.
So if you wanted to implement like something with insertion, either you would have to do it in the original list or use the methods you already have.
Right. Yep. And this is a good constraint because the idea of private is that literally nobody who is using this class or even extending it ever needs to know anything about its internals. That's the conceptual picture. Private is a hard wall around this class, even its subclasses.
Does Java have like a protected keyword?
Yep, it does. So there's two other levels of interface control. There's public and private that you know, and then there's also protected and package private. But we don't write big enough software for those two to be useful.
Okay.
Somewhat puzzlingly, the keyword for package private is no keyword. So if you ever forget to put public or private, that's because you're actually doing package private, which means only items in the same package can use it. Yeah.
All right.
Noah.
Hello. So after I finished watching your lecture today, I got like recommended a discussion from last semester or something. They went over inheritance. And they said something about like an abstract class, like an actual abstract keyword.
Right. Yeah. So there is another feature of the Java language known as an abstract class. It's kind of in between an interface and a class. So it's a little more concrete than an interface, but not as concrete as a class. In case you're curious, the difference is that an abstract class can have instance variables. That's, I guess, the biggest difference. I used to have abstract classes in our class, but then they introduced the default keyword in interfaces. And once they did that, I didn't really need abstract classes anymore. They are useful, but just our programs are not big enough to make it worth your while. Let me give you an example, though, since you asked of why you might ever use one. So let's say you wanted to write your own list class, right? Which is a thing you might want to do. I want Java 15. All right, so the good news is you can do that. Like I can open up IntelliJ and I can say, my class implements Java util list. The downside is then you need to provide all of these methods: add all, clear, etc. I don't know which of these are default, but there's not very many though, right? Like split iterator is default, replace all is default, but a lot of this stuff is kind of a pain, right? Like you would need to write your own toArray and sublist and of all this, right? So it would take you a long time, like half a day. However, there is some redundancy between these methods, right? Like presumably add all, which takes, actually I'll take this add all, which takes a collection and adds everything, is just a bunch of calls to add. So what you can do is there's actually a thing called abstract list. And so if you look up abstract list, it actually already does a bunch of basically default methods for you.
I see.
So it gives you all kinds of different methods, and you only have to write actually a certain, sorry, abstract methods. Yeah, so technically, that's interesting. How is that? You can do it with only get. Huh. All right, anyway, so you can technically implement only the get method, and you'll have a list apparently. Yeah. Now you might ask, why is add all in the list interface? Why isn't it default? And that's, I'm guessing, just for legacy reasons, because default didn't exist back in the day. I don't know if that made sense.
Yeah, I think that makes sense. Yeah, so you
Yeah.
answered my question. Thank you.
Yeah, cool. Anyway, something we're not teaching this semester. There are many things in Java we don't teach because I want to focus on the data structures and the decomposition and not the language details. Let's see. All right. Pratyush.
Yes, hello, Professor. So for higher order functions, we have to use an interface, but that is for Java version 7. So do we still need to know it? Is there a different way to do higher order functions that we need to know of?
There are no other ways you need to know how to do it. The Java 7 way is the most common way. That's how real code tends to be written. So that's actually the only one you need to know. What you don't need to know is the Java 8 and later way, which is the, let's see. Well, it's not actually in lecture yet, right? I think this is lecture. Oh, no, here it is. Yeah, this one right here. So you don't need to know how to use this stuff.
Got it. Thank you.
You got it. Yeah. It's used pretty heavily, though, in certain types of code. Somewhat vexingly, the new version of JUnit uses this stuff very heavily. And so I haven't switched to JUnit 5 specifically because there's too many higher order functions everywhere using weird syntax.
Oh,
One day.
thank you.
All right.
Yeah.
Daniel.
I just had a couple of quick exam related questions. So is it fine if we just like for particular methods that have like, I guess I think like equals or like thinking about, I guess, where the what you're inputting into the method, the type matters. Should we be considering using like get class or like get like super generic or get generic class or whatever the method name is?
Well, I'm very curious why you're asking. I will answer, but I want to know why the question came up.
It's because I think for one of like the questions in the practice exam, I kind of wasn't sure whether to like have a case to account for like different types.
Got it. Which question was this actually? Do you have it open in some way that I can see? I don't know if I can dig it up.
I'm going to search for it.
Okay, yeah, go for it.
But it should be question 5, part B. So like the contains Java.
Okay, let's see.
It says it should work for all possible inputs, not just for the JUnit test above. So
got it.
My interpretation of this is, yeah.
Got it. I think you're definitely overthinking it, but let me figure out why. So first of all, I guess I'll note we haven't talked about get class yet because it's, I think, lecture 13. But let's see. So this was. Sorry, I gotta. It's gonna take me a second. If you have the question handy, by the way, and you want to screen share it, you want to do that?
Yeah.
Okay, I'll just do that. It's just so much faster. Okay, let me give you the power to screen share. Okay, there you go.
All right, so for something like this, right?
Sure, yeah.
I had like the idea to like get like the generic superclass and make sure that it checks out.
Got it.
And then if it doesn't, then return false. Otherwise, just do the actual comparison.
If get class, what are you supposed to write? Go back up. You want to write the method contains. I see. So someone gives you a T, and you want to see is it equal.
Like, I guess my impression was that
Yeah.
like you could enter in like a string,
Mhm.
or I guess like do the dot contains method on like a string array or something weird. And so I was trying to ensure that the class was a subclass or implementation of list 61B. And so
So the current object, right? No matter what. Actually, walk me through semantically what's going on here. So you're saying it's false if what happens? If the current thing is not even a list, is that right?
oh, I see.
I mean,
I
that's
see
not
where we
reading. Is
don't.
that what it does?
Okay. No, I think I understand where you're trying to go. It's that like this method it only exists inside list 61B, and so
Right.
we'll never
Yeah.
even.
Yeah.
Yeah. Okay.
Yeah. No, one thing, like, let me give you an important pro tip, which is that if you find yourself leveraging like obscure reflection knowledge like this, you're definitely overthinking it. Just because I haven't taught any of the reflections data, any of the reflections stuff in class, like Git class, and certainly not
Right.
Git generic superclass. So, which I didn't know existed. Yeah. So if you find yourself leveraging like sort of Java Arcana, you're probably going out of the lines we expect.
All right.
Cool.
Technically though, this code does work. It is
Yeah.
like 8 lines. So
Yeah.
would this like still count toward?
Sure.
Okay.
But it checks something that will never happen, right?
Yeah.
Because whatever is happening must be a list 61B.
Yeah.
Yeah.
Okay.
Cool.
That makes sense.
Out of curiosity, under what circumstance have you had to learn any of the Java reflections library, which is like the Git superclass stuff?
I think when like implementing like when we have like a dot contains for like a different object. So like if we pass in an object for what like this isn't really so much compare, but like methods like equals or something like that.
Right.
You have to check the actual
Yeah, certainly
class
the
of
type
whatever.
checking I'm familiar, but I don't think I've ever, as I mentioned, I've never even seen Git generic super type. Like, how'd you know Git generic super type existed?
I looked at Stack Overflow.
Ah, right. Okay. Okay. Just curious. I was like, well, that's going out there in the strange world. Cool. All right, Steve.
Hey, Professor. A couple of questions. So for my first question, I want to know like just conceptually what like I kind of have an idea, but I want to know like what you expect when you ask for like non-destructive and like destructive operations.
Right. So destructive and non-destructive are terms that were used in prior iterations of 61B, but they were only used in lab, and they were clipped out because we don't really use it anywhere else in class. So I suspect destructive and non-destructive, this must be from an old exam, but let me explain the term just so you know it. If it happens on an exam in the future, I'll re-explain it. But destructive means, or sorry, non-destructive means the object that you are operating on doesn't change. So imagine, for example, a non-destructive operation that returns, I don't know, the last 5 items of a list. So what it should do is not actually change the list. Like, it shouldn't destroy all the stuff at the front of the list. Does that make sense?
Yeah.
Or like, imagine a function that takes 2 arrays of integers and sums them. A non-destructive version won't change either of the arrays, but a destructive version has the option to. And so what you might do is like use one of the arrays to store all the results, and that would change the original. So that's all it refers to.
Cool.
Yeah, but I haven't taught the term, so it's not surprising that you didn't know.
Yeah. Okay. So I have a question relating to that. Okay. So if I want to like basically perform a non-destructive operation on a list, for example.
Yeah.
Say I want to do a recursive operation, for example. Yeah. You talked about something like basically like getting another object to point to maybe, for example, like a node or so. But I find it hard to do that in the case where you're actually traversing like a whole list. If you understand what I'm saying? Because if I want to do that for a node, then it's easy. I could just like say this node equals this, and then like manipulate the pointers around.
Yeah.
But then like if I have a whole list, I find it hard to know like how to perform a non-destructive operation on the whole
Right.
list, if you understand what I'm saying.
So
Like
to do that, yeah, you'll have to actually create a new list as you go. That's the key difference, is that you will need to be using the new keyword for any value that you would be tempted to change, right? So let's imagine trying to write a method that recursively adds 5 to every item in an int list. Then you're going to need to be calling new a lot of times, basically.
Cool.
Makes sense?
Okay.
That's the key, is to realize that there's a new every single piece of data you want to store.
Cool. Thank you so much. And lastly, Professor, I have a question about like basically compile time and runtime errors. I know we spoke about something like, you know, the static types and the runtime types, basically. So does that have anything to do with like basically like compile time errors and runtime errors?
Yeah, sure.
Because
thing.
or in general, when you say that, what do you like? What do you mean? I know compile time errors are like maybe mostly syntactic errors and stuff like that, but
yeah, I think it's fair to say that there's a bunch of different compile errors that can happen, like of course syntax, but in Java at least one big type of such error is type error, static type errors in particular. So for example, if I call, you know, x.jump, but the static type of x, whatever it is, does not have a jump method, you'll get a compile error.
Oh, okay.
So I would say that static types are used to check, or sorry, rather, you can think of compile errors, compilation errors as having two variants. One is type errors, and one of them is everything else. Yeah.
Cool. And Professor, like there was a question in the midterm which asked about like, you know, making a new list or something like that.
A new list.
And in general, when you say a new list, do you mean like an A list, or basically like the list described in the prompt? Because I think they were talking about like an int linked list or something, or so, like something like that. And then we had to create a new list. So in general, when you say new list, do you mean like the same? When you say list, do you mean the same kind of list that is?
I see. Good question. So if we let me do screen sharing. Okay, so let's suppose we did you know, have a list. Let me see if I got the idea here. So let's say we had just to make up something. Let's say we did like so tell me if I got the question right or what you're asking. Some methods not shown. So if you tried to write this default method here, and it said returns a new list with items from index start to index end. Is that what you mean when you say a new list?
Something like that, yeah.
Yeah, so I should note, like if you're returning a list, one thing you can't do is you can't say, you know, new list t. Right, like you can't do that, that's impossible. Lists are interfaces, you can't be instantiated, right? So then your question was, are we required to create a new list of the same type, dynamic type, as the past as the current list? So in other words, let's say you had a list t equals new a list, or sorry, integer.
So before you go, what do you mean by laser interfacing can't be instantiated?
So here, so the list up here is an interface.
Oh,
so you can't
okay,
do
okay.
New list, yeah.
Okay, but if it's like an implementation of that interface, you can.
Right. Yeah.
You can do that. Yeah. Okay.
Yeah. So then I think what you're asking is, do we have to make a new list of the same type?
Yeah.
Right. So let's say we do something like a.add 5, 10, 15, 20, and then I wanted to do a.sublist 1, 2 or something. So we have this right here. So your question is basically, does the returned list need to be A list. Now it turns out that there's no easy way. I mean, you can do it using tricks like what Daniel just showed briefly, where you can get a new list of the same type. But what I would probably do is just, yeah, like, actually, let's make it a linked list. That's different, or S list. There's no way with any syntax that we have that this sublist method can like make a new list of the same type. You know what I'm saying? Like you just, in this case, I just had to pick one. Does it make sense?
Yeah.
So I guess I would just say no.
So the answer is no. Yeah.
Yeah.
But why can't it be? Why is it going to be difficult for it to be a list of the same type though?
Well, what would you write here? I guess is the question, right? Because when you're writing sublist, this is a great philosophical question. How would you know what kind of list you are?
Oh.
Does it make sense?
Yeah.
Like at the time that this code runs, it is an S list, but there's no way that this code, like we don't have anything in our list of Java syntax features that allows us to say like new, me.type or whatever, you know what I'm saying? Or like this.type. Like that's not a thing we know how to do in Java. So we can't just say like make a new copy of me. You just have to pick a list type. Make sense?
Yeah.
Yeah.
Kind of.
Well, I mean, I guess my question is like, let me syntax highlight this thing. I mean, I might have read into your question incorrectly. I don't know if this is what you're asking in the first place, but like, so as my code is written right now, let me ask you this. What is the dynamic type? What's the dynamic type of return list, Steve? Based on looking at this code.
It's gonna be the type of sublist. Like, let me see, A or sublist. It's gonna be list, right?
Well, that's
list.
the static type.
Static type is list.
So the dynamic type is like the actual type of the object as it was when someone called new.
Yeah. So okay, it's gonna be S list. It's gonna be an S list, right?
What do you think? I mean, yeah. Or so tell me. Sorry, not what do you think? Why do you think it's S list?
Okay, because A had a type of S list instead of dynamic.
Well, but the trick is, where did this list actually get created? I didn't actually tell you. Maybe I left off the detail here. So this list right here.
Yeah. It's sublist.
Yeah, the one that's returned by sublist. So sublist is a function that returns a list. Mm-hmm. But this list actually gets created on this line. Does that make sense?
Yeah. Oh yeah. Yeah, I see.
Yeah, so the
dynamic There's gonna be list, right? Not S list.
Yeah.
A list, yeah, A list.
Yeah. So the dynamic type is A list because of this right here. And so what I thought you were asking is, does this dynamic type here need to be the same as the one up here? Actually, I guess I have another question for you. What is the dynamic type of A?
A. It's S list, right?
Right. Yeah.
Oh, yeah, it's S list. Right?
So you'll notice is that like S list and A and A and returned list have different dynamic types. So in other words, this list you started with is built using linked lists, but the one you get back is based on arrays. And so someone might think that's weird. And so I thought you were asking, is there a way you can make sure that this list that comes back is the same dynamic type? But we don't have a way to do that. That was what I was getting at.
Okay. Yeah, I mean, you probably overread into it, but this answers a great deal of it as well.
All right, cool. I hope it's helpful. Yeah.
Yeah, it is. Thank you.
Sure thing. All right, anybody else in our remaining 0 seconds?
I guess just like adding on to this, like, can you think of like the return type as like a casted, like the type itself is like casted in front of like whatever, I guess.
Yeah, you're saying it's like it's basically a cast into a list. Is that right? Is that what you're saying?
It's like casted in front of whatever a.sublist technically deals with. So like when you call a.sublist, you have like a cast within the sublist method of
Yeah.
whatever you want to return.
Yeah, that's right. I think it's way to think about it. Like this, it gets applied like right here. Sure, it's the equivalent of casting.
Yeah.
Although you don't actually need the cast. Like, I mean, you could think, oh, it's kind of doing this, isn't it? But yeah, I actually think about the following. An A list is a list. So it's not really casting in my opinion, but you know, I get what you're getting at. For your sake, or for your edification, by the way, Daniel, there is a way that you can say this dot get class dot like get constructor dot get instance. So you can do it if you really want a list of the same dynamic type. But I don't know if it's the right syntax, but it's something pretty similar to that. Anyway, everybody else ignore that now.
All right.
All right, cool. Don't do that on exam. All right, see ya. I'm excited for the midterm. All right. Anyway, see ya, everybody.